Teresa O'Donnell Sloan, and I'm a senior at Pomona High School in Arvada, Colorado. And today we'll be talking about integrals. There are two types of integrals. The first one is an indefinite integral, which allows us to find the antiderivative of a function. And the second one is a definite integral, and this integral allows us to find the area underneath the curve which has been created by the function over the interval of a to b. Without using calculus, we would use an estimation technique by using rectangles to section off the shaded region in which we have to find the area of each separate rectangle, and all the rectangles have the exact same width but changing heights, and add all their areas together to find an estimated area of the entire shaded region. So integrals are so amazing because they use an infinite amount of rectangles, therefore allowing the accuracy of our area to be 100%, because as our number of rectangles within the shaded region increases, our accuracy increases and our estimation of error decreases. This is our notation for an integral. It shows, for a definite integral, this shows integral of a to b, f of x dx. F of x is the part you change in the function given, which is associated with height, and width is never changed and is associated with d of x. Now let's apply it. Here's the problem we are going to solve using a definite integral. This is the graph, which shows what we have to find. Here is our function, and that is the integral we are going to use. Okay, now we're going to solve. Here's our integral, and here's our function. The first step to solving is we have to break up the integral. We will do this by giving each component of the function its own integral, or breaking it up by the addition and subtraction. Then we're going to separate out the constants and the variables, and both these are specific rules for integrals. Here is an example right down here. Now step 2, we are going to use an indefinite integral in order to find the antiderivative. And we are going to use this notation, which is the integral of x to the n dx becomes x to the n plus 1 over n plus 1 plus c. And plus c is the constant which is unknown for our new antiderivative equation, because the derivative was once taken and that constant turned out to be 0, so now it is unknown. So we leave it as c, and here is this step applied to r. Now we are going to use the fundamental theorem of calculus, which states that if f of x is continuous over the interval of a to b, then the integral of a to b fx dx equals f of b minus f of a, where capital F, seen here, is the antiderivative. So therefore, when applied to our plastic problem, it would be the antiderivative function f of 17 minus f of 5, which turns out to be, here's our answer, which is 347 million tons of plastic was generated between the years of 2000 and 2012 in the USA, and here's the work, the 3 steps in how I got that answer. Thanks for watching.